dictatorship. And other ones were working quite well, and then underwent a revolution funded openly by another party to put in a dictator to get better trade on things like bananas. You want to look up the banana trade?
The banana trade is terrible.
At all levels.
It still is.
Okay. I'm going to ask Aiden. He's still talking. Aiden, what is potential energy from chemistry? I'm not going to let you get away that easily. What does the word potential mean? Kinda.
It's like God.
Kinda.
Kinda.
And what do you mean by kinda? If I say potentially you have kinda energy, does that mean the energy is currently being used?
It could be.
It could be.
Yeah.
Possible.
Perfect.
Possible.
So, what was the potential energy in chemistry?
Energy stored in bonds.
Energy stored in bonds. And that's still true. And all the types of energy we're going to talk about, the energy stored in bonds can do the same things. We can transfer it into other forms. We can make it do work. The entire internal combustion engine is designed for that. And so chemistry has that. But we're not going to focus it in the physics side, because we're going to do a different version of energy, a little easier to calculate. Bond energy calculations you can save till university. But this type is a little different. I'm going to demo it.
What's happening right now? I won't be scared.
Now, Rose, you're looking particularly nervous. I am feeling very nervous because I have more potential energy. Why do I have more potential energy? No, you've answered a lot.
Because you're off the ground.
I'm off the ground. What do I possess off the ground? What could you measure? Yes? You got your hand up. Sorry? Oh, yes. I am heavy. Well, everybody's heavy. I think what you're looking for is I'm heavier than everyone else, and everybody's going like, oh, look, the old man's about to die. Because if you fell, like, what, you'd bounce probably, you might break an arm. I will definitely go splat. And then you'll have to call 911. Please call 911. Because there will be a terrible accident. However, so mass makes a difference. Because you know if you're sitting at the bottom and something hits you, a tiny little pebble versus Mr. Neufeld would make a fair difference in the amount of energy. But but I was on the floor before. Nobody seemed to be particularly concerned. And then I got up on the table, and now I'm dancing. Not quickly, in case I fall off. Yes, keep going.
It's because you can jump farther from there.
Like, are you worried I can jump at you? No, just consider it in case of like jumping down or falling, not like threats.
There's like
More height.
the energy.
And we can measure the amount of energy in centimeters with a couple of other factors. How could I get more energy?
Go higher.
Sorry, hands over here, yes?
Go higher.
If I go higher, I can climb this.
Yeah, we should swing off
This
that.
seems really useless for
Grab
climbing.
onto the metal beam.
I could grab onto the metal beams. To be honest, I don't think these would hold
No,
weight.
no,
I don't even
no.
think those are like aluminum. They're not. Oh God, no. Those are decoration. That feels like particle board. It is not aluminum. It's not metal. I'd have to like really jump up. Maybe swing on those electrical cords if they were. I am not going to do any of those things. If you're saying.
Jump onto
Um,
that ledge.
I'm not jumping anywhere. So I have more energy. You can calculate how much more energy I have. If mass is involved, so we did fantastic. Height's involved. There is one more factor. If you get that factor, we have all three factors for this type of energy. It relates to speed. It has to do where I am.
Gravity?
You just yelled it out.
I might have
Oh, I know.
Yes?
Gravity.
It is, in fact, gravity. Well done, Liam. Because would you be as worried if you saw me on a desk and I was like floating in outer space?
Yeah.
Well, you might be for different reasons, but you wouldn't be worried about the height. If I was standing on the moon on a desk, that would be cool. And also not nearly as worrisome, provided I wasn't gasping for breath, that I had a spacesuit on. Because the amount of gravity would differ. On planet Earth, we worry because of the amount of gravity. The smaller you are, the safer you are. Mice can fall almost any distance, and they will not die.
Empire State Building?
Because on Earth, what slows you down? Like, we're not going to consider this in our calculations, but there's something that slows you down. Air. So there's air resistance. A mouse is light enough that the air resistance will actually keep it below the fatal speed, what they call terminal velocity. Whereas, like an insect can fall any amount, just like bouncing, not even get hurt. A mouse can fall, maybe it gets a bruise or something. A small cat can pretty much fall any distance as long as it falls on its feet. It's got enough strength to go ping. Larger, very large cats and dogs start to get to broken bones, and a horse will go splat. There's very little height a horse can fall from and be okay. Same with a large human.
What about a small human?
I have observed babies bounce, but they generally say stop doing that. So I'm not allowed to test that anymore.
What? Why not?
I know, I don't know why not. So,
Yeah, the board of directors.
so we have. Oh, I should have put stored in front of this. Stored, because it's all stored. Stored energy in height. And sometimes this is called energy of position. And it's all related to the fact that we're on planet Earth and things naturally have more energy the higher they are. Why are you on your laptop? Put those, keep those up. No shopping for shoes now. That would apply to both of you. No, I know, but I like the way your laptop is open. You looked over and like, yeah, what are you doing? And your laptop is also open. Potential. We did that. I like that. It's the could happen is the English definition. And physicists are not silly. They like to pick words that relate, but everything that's defined in a science has a very specific meaning. So this is not the meaning in its entirety. This is the English definition. And you do have to be a little careful about that. Like I've heard people use an argument. Well, it's just a theory of evolution. It's not like it's true. And like, yes, when we say theory, I have a theory how the crime happened in common vernacular or common English. That means you have a guess, a hypothesis. But in science, a theory is a well-tested, established set of reasoning that is supported by multiple pillars of evidence to show that this is true. Like the theory of gravity. So saying the word theory is not they're mixing up English versus science definitions. Potential in physics means the energy that can be converted into work. And work is another thing that has a physics definition and a English definition. They're close. What's the English definition of work? That didn't catch. Yes!
Like a job.
A job. Hang on. Like what, if you're doing work, some of you would have jobs, some of you do not, but everybody uses the term work. What do you use the term work for to me that isn't a job? Yep.
Doing productive things.
Productive things. As opposed to fun things.
Some fun things are productive. Like physics.
No, none of them are.
What about chemistry?
It's not fun.
Oh, I've been hoisted on my own petard. So yeah, doing productive things. Any that people want to add?
Doing something you have to.
Things you have to do. Like visit your mother.
I know.
Mm. And energy and work are measured in joules. Now that's not a, that is, what? What are you doing? Don't distract me.
No, you distracted me.
I had to turn you around. That doesn't work. Don't make me move you. Go this way. Focus.
Eyes focus.
Okay, we've got joules, and this might seem artificial. We've told you things are measured in different things. Time is measured in seconds, and minutes and hours, but seconds is the SI unit, the Système International, or and that is the while the French were cutting off heads, they also invented the metric system.
Yay.
Things we didn't adopt. 10-hour day. There were metric systems for everything, where an hour had 100 minutes, and all sorts of things. But we kept the 24-hour day. But we did make a lot of other changes, and some of it is very practical. If you want to know what a kilogram is, you just need to get a milk jug, fill it up, and a milk jug is how many liters? 4. So if you fill it up, you have 4 liters. That means you have 4 kilograms. 1 kilogram of water is also 1 liter of water.
Roughly.
1 cc, if you get injected. 1 milliliter, a milliliter is not a magic unit. A milliliter is a unit of volume. So it's a cubic centimeter. 1 centimeter by 1 centimeter by 1 centimeter is a milliliter. That's what a milliliter is. And so all these units interrelate, and sometimes they get really complicated. So we don't want to say centimeter cubed, so we say milliliter. We don't want to say what it actually is, so we say joules. But I'll show you what it is, because let's do the bow first, and then I'll show you. So you are going to have to draw. So let's draw the bow. You need a handle. And now you need the bowstring. And you need an arrow. Make sure you put some fletching on it or it won't fly straight. And then it shoots. When you redraw it, it should be slightly straighter because it released some of that elastic tension. And maybe the string hangs down a little bit. My glasses are falling off. And this, an outstretched string, has potential energy. We release it. was about to draw Mr. Neufeld and it puncturing in the same way that I had bullet wounds in the Prime Minister. And then I realized this is being recorded. It might be a little violent. Remember when I saved the Prime Minister? In our ethics discussion. And we had to decide who to treat first.
When did we talk about this?
When we did ethics.
I don't think we talked about that with this class.
What?
We didn't do the Prime Minister getting shot.
If two people arrived at the hospital at the same time,
Yeah.
and one was the Prime Minister, and one was Mr. Neufeld,
Treat them the same.
Oh,
what if you find out that Mr. Neufeld has very severe wounds, and the Prime Minister has very light wounds,
Mr. Neufeld.
Mr. Neufeld. But what if you're a utilitarian? Probably the Prime Minister, because he needs to be back on duty. People might actually be dying because even though his wounds aren't that severe, there is a consequence. Whereas deontology wouldn't consider that as a consequence. It would consider rights. Also, what if I shot the Prime Minister? This is being recorded, and at the current time, CSIS shows up. This may have been a bad idea.
You would need to be treated so you could get your day in court.
Right, and so deontology would not consider the fact that I shot him. Utilitarian might not as well, because they would have a vested interest in making sure that things are investigated properly, but they might anyway. And so this is to show that it has hit that's not a very good target, but try your best. I can't remember what the colors are. I think they're blue on the outside and then white and black. Anyway, draw a better target than I did. That's to show that it stopped. And right here we have 100 joules. Foosh, it flies.
We have to draw this all.
Yeah. Right now, of course you have to draw this. I just realized I put that one in the wrong spot. I should have put it here. So, what is the KE? The kinetic energy of that arrow. We start off with 100 joules of potential energy.
Oh, the air. We need to know how the air friction works.
Well, just give me an estimate.
Probably like 70, 60, or
Seems good.
like 600.
Kinetic energy could be 70 joules. So where's the other 30?
It is dissipated in the air.
Okay, so
The friction took it.
friction, let's say 10 joules. Where else would it have gone?
Friction.
Well, we already said friction. So specifically, this is air friction. But there's other things that have happened. Like when you shot it, did you hear it?
Oh, it hitting the bow. Like with the beams.
So sound.
Arrows, bend.
Let's say 5 joules. String wobbling, because after you shoot, the bow and string probably have a wobble. So let's say bow and string wobbling. What are we at? 70, 60, 70, 80, 5. Let's make that 5 joules. Anything else? By the way, the air friction, you could also just say heat. Have you seen the YouTube video? Like, can you cook a chicken by hitting it?
yeah.
Someone has proposed, because if you hit something, you're just creating friction, which adds heat. And if you hit it enough, can you spank a chicken until the point that it actually cooks? Someone did a YouTube video, and they said, yes, you can, because they got it to raise in temperature by a couple of degrees. I'm not going to eat that chicken, and I don't think you can cook it. You also have to get it hot enough, but
Arrows bend as they travel through the air.
physical and draw a little arrow because it would wobble. And that's pretty good. So what are we at? 70, 80, 5, 90. Let's put that at 10 joules and then we're done. And so energy is converted. What color haven't I used? Dark blue. And so when we say work, I still haven't defined other work. I'll do that one after. We're not going to, I don't think we're going to use that much work. We're going to do energy first, so we don't have to define it right away. But it is, what I'll just say out loud is that when we talk about work, it's measured in joules as well, but it refers to the amount of useful energy you can convert it into. So we would calculate it for the arrow, simply the 70 joules would be the amount of work you got out of that, accounting for the other factors. And there's a way that you can calculate the amount of work that something can do. Horsepower is an old version of work. It does not literally relate anymore to a single horse plowing a certain amount. That's why horses themselves have multiple horsepower, if you know anything about it. But we could do a calculation right now because the potential energy for height is equal to the m, g, and h. What does M stand for?
Mass.
No, I've got a lot from in here. I had a few there, a couple here. I feel like got a couple in there, but back there and here I don't have that much from. What is M? What's M? Mass, sure. What do you measure mass in? Pardon? What do you measure mass? You said mass, right? What do you measure mass in? What is mass? Anything? Light is mass. No. It is something that has volume. Oh, that's a really good point. Something that has mass usually has volumes. There's one exception, but well, it's the exception the other way. Never mind. Light has volume and no mass. Weight is a really good way of putting it. Mass, weight on Earth, and the reason I have to say weight on Earth, and I have to circle that because the physicists are going to be really mad at me that I say that, because weight is not measured in what I'm going to ask you. But when you get on a scale, a metric scale, what do you weigh yourself in? Not a metric scale. If you're Canadians are weird. We measure our weights in our personal weights in pounds. We in the grocery store, it's often kilograms. We measure our pool temperatures often in Fahrenheit, but our outside temperatures in Celsius, we're all mixed up. But the metric system, mass, is the kilogram.
I thought metric was pounds.
No, that's imperial. Pounds is old. Kilograms is metric. There's 1,000.
Is metric, right?
There's 1,000 grams in a kilogram, just like there's 1,000 meter in a kilometer.
Okay, wait. Kilometers metric.
Yep.
Yeah.
Yep. No.
Why would it be 12
Okay.
ounces to a pound?
We had one from Evan. what anyone from this table, what does H stand for?
Helium.
Height. What do you measure height in metric? Feet is imperial. Meters is centimeters is metric, but it's just a smaller part of the meter, which is the useful one. Weirdly, we use kilograms, not grams. Grams is technically was supposed to be it, but physicists and chemists looked at that and goes, grams too small. We use kilograms, still metric. So height H is height, and it's measured in meters. And these have to be consistent, because if you use different units, then your calculations will not be the same as someone else's calculations because you're using the wrong units. So we have agreed upon these units as a scientific community. We will always do mass in kilograms, and we'll always do height in meters. And if you don't include your units, it is assumed that's what you're doing. We crashed a multi-million-dollar spacecraft on the surface of Mars because the European Union and the US used different units and they didn't tell each other. Weirdly, the European Union put in a calculation in which they had used imperial units, which is weird because they use the metric far more often. It's the American scientists that are more likely to say use imperial once in a while. But the Americans put it in, so it successfully got all the way to Mars. It got to its landing spot, rotated around, went to orbit, and then started dropping down to gently land, and then accelerated and smashed into the planet before anything could happen, because the calculation that went in used the wrong units, and they forgot to tell each other. And so it's kind of important. We know what your units are. You do have to put your units in all of your calculations. And the last one, G. Pardon? Gravity. And now open up to anybody. Does anybody know what the acceleration of gravity is? Yeah. So G is gravity. Does anybody know the units? Pardon? Meters per second. Gravity is not a force. It's an acceleration. And I misspelled acceleration. I think I have the wrong number of L's, but ignore this part. If this is 0 seconds, this is 1 second, this is 2 seconds, sec, that looks weird, 5s, sec, 3 seconds, 4 seconds. Just to give you an idea, Mr. Neufeld, despondent, because his classes are too smart and they're learning so well, nobody even needs him anymore. They're getting straight A's across the board. So I climb up to the top of the building and I'm going to jump off. But at the last minute, I have a trampoline. It's actually a stunt because otherwise this whole demo would be too depressing. So giant trampoline in the bottom. I'm going to hit it with all the energy and hopefully fly back up. However, I jump off. In the first second, knowing that gravity is 9.80 meters per second squared, what does that mean? How fast? Here I'm going 0 meters per second. How fast am I going in 1 second?
9.8
It
meters.
can't. Yes.
9.88 meters.
I have gone. Well, I may not have gone because I accelerated over that time. So I won't say the number of meters. That's a different calculation. But I am now going 9.8 meters per second. How fast am I going at 2 seconds?
Fast.
Yeah, how much faster? Yes? 39 is too fast.
19.6.
Hey, way to read it, Matthew.
Yes?
19.6.
19.6 meters per second. What am I doing at 3 seconds? I don't think I've heard from you. Let's go. 9, yep.
9.44.
Yeah. 4 seconds. You've already done one, haven't you? I haven't heard from you. You didn't even have to do math in your head. Just look at the pattern. I was 9.8, and then I went 19.6, and 29.4. There's definitely a pattern. It went 9, 19, 29. What do you think the next one will be? No, don't listen to him. Just look at the pattern. No, don't listen. But 9, 19, 29, 39.2 meters per second. So gravity is a change. Does everybody know what that symbol means? That means change in velocity over time. So it is, one second, 9.80 meters per second. So every second you're going that much faster. So you're driving down the road. If you're doing 10 kilometers per second, or then the first second you're just going 10 kilometers per second. Well, let's not do that way. Let's relate it to more speeds you see on the highway. Let's say you're going 10 kilometers per hour. So by the time you hit the end of you slowly move up in speed. And then at the end of the first hour, you're going 10 kilometers an hour. It's really slow. Second hour, you're doing 20. And the third hour, you're doing 30, then 40, then 50. And that keeps going faster and faster and faster. That's how we get spaceships out so fast. They have a very small amount of force in the rockets that's pushing them. But the acceleration never stops. There's no air friction out there. So those can get up to tremendous speeds. Because over time, it just accumulates. And then like here, they don't have air resistance to slow it down. Your hand was up.
No.
I swear out of the corner of my eye I saw this. Ooh.
What is the terminal velocity for an average human being?
For a what?
The average human being.
Oh, I looked that up. I don't know. Let's consult the oracle. It may not be right, but everybody will trust it. What is the terminal velocity of a average human being? Oh, ChatGPT. ChatGPT says, like, you can actually look this up, but I don't know where to get the thing right now, so let's see what it says. It says network problems. I'll let it think. ChatGPT was really confused by that question. Okay. Okay. We have 15 more minutes roughly. I should have given you a break in the middle, but we had such a big one at the beginning. I'm going to show you what a joule is. It's not the most amazing. It's the most amazing demo in the world. But I'm going to give you 5 minutes right now. Once again, you cannot walk to your house. If you leave the classroom, it's to go to the bathroom, then come back. You can grab your phones if you want. Please put them back in at 11:37, which is what I announced. Yes.
In a belly to earth position, the human, average human's terminal velocity is 200 kilometers.
Dude, Rose has them.
Interesting. Yeah, that's close to what ChatGPT said. ChatGPT said 193, which is basically 200. And also there's if you dive head first like a lawn dart, they can increase. Oh, by the way, terminal velocity is not the term for the speed at which you dive.
It's a speed that matters.
And it's the fastest speed you can get to. Yeah. If you dive like a diver, you can get up to 320 kilometers an hour. That's fast. Yeah. Classic skydiver stat is apparently 120 miles per hour. Because ChatGPT is American.
Does it continue increasing over time?
Yep. But on Earth we have a natural limit.
I'm going to tell my
because
dad.
as you go faster, you have to push air out of the way.
Yeah.
And when you're going slow, that doesn't take much of a
Yeah.
difference. But the faster you go, the more the air tries to stop you. And it takes even more energy to accelerate.
Yeah.
So if you're using the same amount of energy,
yeah.
there's a limit to how fast you can go without putting in more
So
energy.
it kind of goes like kind of
Yeah, a little. Now you can always add more energy and get the air out of the way faster. Sometimes it's helpful to think of it, if you're trying to move something in water, you know instinctively
okay.
that things slow down in water, and it would take a lot of energy to move it through. And the faster you go, the even more energy it does. There's a design for a submarine or a missile underwater. It actually produces a shockwave in the front that makes a vacuum around the rest of it, so you get rid of all that resistance except at that spot. And those can go extremely fast. And kill all the fish and wildlife.
You know, I guess Blake's a friend of Mr.
How much more
Wister.
time do we have?
Until 37 on the clock.
Can we turn the temperature up?
Oh,
I told him not to
turned
tell
it
Mr.
down.
Wister. I don't, he's not. I said don't tell Mr. Wister.
I'll compromise that one. I wanted it,
upset, but that was a bad joke.
and I won't compromise it 90, but it's literally cooling before, so it should.
I have much respect.
It stopped
for
cooling now.
Rick Levan.
No, allow it to I unfortunately brought a hot, so I have one tea.
So too far, Leo.
Yep, you said this was up.
Unlocked the last building.
Square, yep. What are weights? Newtons are for force. So we talked about weight, and when we say how much do you weigh, we're referring to mass. In physics, if you talk about how much something weighs, that's the force being applied due to the acceleration of gravity, depending on its mass. So weight is actually measured in newtons.
Mr. Neufeld,
Yeah.
have you ever played Cookie Clicker?
Played what?
Cookie Clicker. Look, I'm buying Cookie stuff on Cookie Clicker.
Look at these youths on their phones. Does everybody know the regatta job?
They gave me like 2 different ones.
What?
They gave me safety, like finish line, and put me on bowling.
Check with your advisor. Some jobs only need you at one time on one day, and so they put you in a second one because the other one's not going to take up the time.
They like sent me 2 different ones.
Oh, email them both back and say,
One
like,
of them is final.
oh, sorry.
Yeah.
Did you also get that one?
This super okay.
Yeah, but you know.
No, we might have a job anyway because we only raise one. Okay, so no, good.
How do you calculate force?
Oh.
You mark the finish line. Maybe this is a mistake because I was supposed to do lanes. Maybe everyone gets. Oh, no.
Oh, it's 39. I gave you too much free time. You've had a whole extra 2 minutes. Could you please return your phone to the box? Or, if you're very good, just put it straight into your bag and I'll leave you for the last 15 minutes.
Okay, it's in
But
my
if you
bag.
take it out, I get it and I
In
put it
5
in your
minutes.
mailbox, like I'm going to do with Aiden in 5, 4, 3, Boxer bag? Okay. Now, I am going to go through some of, I joke a little when I say, chemistry is the central one. I'm competitive. I'm a chemistry teacher. My first love was physics. I have done the story of how I wanted to go into honors physics, and it turned out those people smelled, so I didn't. But in high school, physics was amazing. You could calculate the answer, and you could actually be right in a way that I couldn't be right in an English essay. I would spend hours on an English essay, and I would get 76%. I would write it the night before, and I would get 76%. And the feedback I got from my English teacher was usually the same every time, and not useful in any way whatsoever. So part of the reason why I may have gone into it is that I had a terrible English teacher. I've seen Mr. Collis's comments. I would have liked to have him. But one of the reasons I really, really like physics is because everything starts to make sense once you understand the math and the units. And once you understand how the units click together, everything, you just realize, everything is actually connected. It's the force that binds the entire universe. We are learning the fundamental laws of the universe. When people talk about looking for truth, it's here, right here. That's what you're investigating. So, the other day I asked someone in a class, because I actually don't have a easy killing, they've taken, there it is. We measured out a liter of water and to get a kilogram. And then I had them weigh textbooks with the liter of water until we got about a kilogram of textbooks. So we're going to say that this is a kilogram. So, sometimes I do this. This is a bad habit of mine. It just means potential energy. Your book does this, and your other things do that. So I'm going to, and other teachers do that. So I'm going to try to be consistent. But if you see me do this, that is the same thing. Potential energy is mass, mgh. So I'm going to take this. This is 1 kilogram. I'm going to get my meter stick, which physics stole, and I immediately stole back. They stole it, and then Mr. Hacker-Temper stole it from physics, and then I stole it back from Mr. Hacker-Temper. Well, not really stole, because I had his permission, thought it was fine. Okay, so I've got a meter stick. This is exactly a meter. So now we can put all these values in. Potential energy. What is the mass? 1 kilogram. I'll only put 1 because this is not measured to any degree of accuracy. So 1 plus or minus 1. And we have h. What's the height? 1 meter. Oh, why don't I move that over so that I can go 1 meter. And then we can put in, what is g for gravity? 9.8. 9.8 meters per second squared. That is a number you should memorize. It's a constant on planet Earth. You should know it. Okay? Multiply that all together. What do you get? Hands if you know the answer. It shouldn't be too hard. Yes! 9.8, because 1 times 1 is 1, and 1 times 9.8 is 9.8. So the real part, though, is, Rose, what do you get if you multiply kilogram by meter? This will feel difficult. It's not. Kilogram times meter is kilogram meter. Yeah. So if you have A times B, you have AB, right? Everyone, like you've done this in math. I'm not.
Yeah.
So, and if you have A times B divided by C, I just want to see where your math is. You know that that's AB over C.
Yeah.
This isn't too out of the bounds. Okay, so if I had A times B times C over Z squared, Rose, what would I get? AB over, pardon? Nope, C's on top. So it's a fraction. On top,
C over Z.
so it'd be A. What, bros? So you keep the ABC. What's left over on the bottom? Z squared. So I didn't hear the square. Also, really important. Sorry, this may be. I won't ask you, given current events, but we don't say Z. We say Z. Some of you, did you not say Z?
You said Z.
Did I say? No, I didn't.
You said Z.
I will deny that to my dying breath.
You said Z.
I did.
so said Z.
My Canadianness is being challenged. I said Z at a camp that was in the United States, and all the kids make fun of me for it, and the counselors then would make me say Z every day.
I would not let you make this otherwise.
Well, I did because like I was 7 and it was in Washington. I never actually did do the demo. We will start with that next day.
Elbows up.
Most of the Americans are they're great. Elbows up refers to our political stance.
But anti-Americanism is one of the key parts of Canadian identity.
I think it's more that the Canadians like to complain.
I disagree, because we're next to such a cultural giant.
We need to develop the separation,
We
yes.
need to split.
But I mean, given the number of